Hey guys, welcome back to the last video in chapter 17. So the last video in chapter 17 isn't specifically acids and bases, but it's something that continues to utilize the same skills, so they snuck it in to chapter 17. If you guys remember back in General Chemistry 1, we gave you a list of salts or ionic compounds, and we said, these are soluble, these are insoluble, and here's this table to let you know if they're soluble or insoluble. Well, one of the things that you'll discover about General Chemistry 1 is we oversimplify or overgeneralize pretty much everything. So this is the first time that I'm going to kind of pull back the curtain and tell you the truth about solubility. So the truth is that even insoluble compounds do dissociate, even if they just dissociate a little bit. But if they dissociate just a little bit, guess what kind of equation we have? Yeah, equilibrium. Okay. So solubility is defined as the amount of a compound, usually in grams, that dissolves in a certain amount of liquid. And this table right here is a table that we gave you in General Chemistry 1 that says, okay, determine if it's soluble or insoluble. If it was soluble in that time, remember we said it was a strong electrolyte and it completely dissociated. So that is still true. If it falls within the generally soluble category, it's strong electrolyte completely dissociates. So anything with lithium, sodium, potassium, those will always completely dissociate. What we're going to talk about today are these guys that were insoluble. So hydroxides, sulfides, carbonates, phosphates. So these guys that are generally insoluble, we're going to look at the fact that, well, they do dissociate a little bit, and we can calculate how much that little bit is. Okay. So this is called solubility equilibrium. So all ionic compounds dissolve in water to some degree. However, some compounds have such solubility, we classify them as insoluble. So today we're going to be looking at the solubility of insoluble compounds. Clear as mud, right? I know. All right, so we can apply the concepts of equilibrium to these insoluble compounds. And determine the equilibrium constant, determine how much they dissolve in water. Okay. So again, we see this K value. So we've got our equilibrium constant, we've got our equilibrium. We use the SP subscript to just say solubility product. So this is to classify it as different from an acid, Ka, or a base, Kb. This is going to be just solubility products. So equilibrium constant for the dissociation of a solid salt into the aqueous ions. So here's an example. So if you look back into your examples from Chem 101 or Chem 1, Gen Chem 1, lead chloride was classified as insoluble. Well, we're going to look at just how soluble it is. It's not at all soluble. It's just a little bit. So we're going to take a look at that. So our equilibrium is going to be such. Our solid compound, lead chloride, will break apart a little bit into lead with a +2 ion and 2 moles of the chlorine. So don't forget that subscript there. So 2 moles of the chlorine. So our equilibrium constant for this is going to be the same as we've been looking at. So concentration of the products over the concentration of the reactants. But what do we see in the reactants? We see a solid, right? Do we put solids into our equilibrium concentration or equilibrium constants? No, we don't. So the equilibrium constant for this solubility product will be the concentration of the products, and that's it. So lead, chlorine, and don't forget to square that chlorine because of that too. Okay. So let's look at an example. These are super, super simple, especially with everything that we've been dealing with thus far. So molar solubility is just the number of moles of the solute that will dissolve per liter of solution. So when we ask these questions, we're going to ask for either calculate the equilibrium constant or calculate the molar solubility, the number of moles that will dissolve. Okay. So here is our problem. Calculate the molar solubility. Okay. So this is an ice table, an ice problem, right? So we've got our equilibrium equation. We've got our KSP. So we're going to do an ice table. So our ice table, remember, only includes items that would be in our equilibrium constant equation. So remember, that's just going to be the ions. We don't include the solid. So on the top of this will be PB and Cl. And I'm going to put that 2 in there so I don't forget. Okay. Initial. Well, there's no mention of the initial concentration in this problem, right? That's not a mistake. So initially, we've got just our solid, right? We've got our solid piece of lead chloride. We're going to drop that piece of lead chloride into water. So initially, we're going to have 0 and 0 because all of it's the solid. What's the only direction that this can change? Yeah, the only direction is up. So you can use X because that's what we've been using. Your textbook uses S because we're doing the molar solubility. Okay. And then chlorine's going to go up by a factor of 2S. So at equilibrium, we're going to have S and 2S. So then we're going to plug this into our K. So 1.17 times 10 to the negative 5th equals S times 2S squared. So let me clean up the right-hand side of this equation. So 2S squared is going to be 4S squared. And then we're going to multiply that by an S. So remember, we add the exponents. So this is going to end up being 4S cubed. The biggest mistake here is not squaring the 2. So you guys get so wrapped up in the variable that you forget to square the 2. So this is 4S cubed. So we want to solve for S by itself. So first thing I'm going to do is divide by 4. That cancels. So we're going to have S cubed equals 1.17 times 10 to the negative 5th divided by 4, which is 2.93 times 10 to the negative 6th. And that is the cube, or that is S cubed. So to solve for S, you're going to have to take the cubed root. So we cannot just do the square root because that will not be the correct answer. For most of you that have like a TI-84, there's a button that has the word math written on it. So you'll hit math. And then you'll scroll down to the 4th line, which looks like this. Okay, so that's the cubed root for this. That's how you type it into your calculator. So I'm going to hit math, go down to line 4, and then I'm going to type in 2.93 times 10 to the negative 6th. So S equals 0.014. So what this tells me is that 0.014 moles of this solution will dissolve per liter of solution. So my answer is just 0.014. That's it. That is the end of chapter 17. So that's it for chapter 17. Now we're just going to practice these skills and get ready for our exam. I hope you guys found this helpful.